Okay, this is skill practice 34% yield practice by Marco Rodella. Question 1. In a certain chemical reaction, 297 grams of zinc chloride was produced from the single replacement reaction of excess zinc and 202.7 grams of lithium chloride. What is the percent yield of zinc chloride? Okay, so first we're going to write out a balanced equation. So Zn plus 2 LiCl combine to form ZnCl2 plus 2Li. Okay, so we then find the mass of zinc chloride by multiplying the initial mass of lithium chloride by the molar mass of lithium chloride to get the moles of lithium chloride, and then we multiply that by the mole-to-mole ratio between zinc chloride and lithium chloride to get the moles of zinc chloride, which we then multiply by the molar mass of zinc chloride to get the grams of zinc chloride. So 202.7 grams of LiCl times 1 mole of LiCl over 42.394 grams of LiCl times the mole-to-mole ratio of 1 mole of ZnCl2 over 2 moles of LiCl. We then multiply that by 136.315 grams of ZnCl2 over 1 mole to get the final mass of 325.9 grams of ZnCl2. We then plug that into our percent yield equation. The actual yield of 297 grams of ZnCl2 over the theoretical yield of 325.9 grams of ZnCl2 times 100 to get the percent yield of 91.1%. Okay, number 2. This one is pretty much the same thing. When 24.5 grams of CaCl2 reacted with plenty of AgNO3, 21.5 grams of CaNO3 were produced. What is the percent yield of CaNO3? So we're going to write out the balanced equation of CaCl2 plus 2AgNO3 combined to form CaNO3 plus 2AgCl. So first we're going to find the mass of CaNO3, and we do that by multiplying by the initial mass of CaCl2, which is 24.5 grams, by its molar mass of 1 mole over CaCl2 over 110.98 grams of CaCl2. We multiply that by the mole-to-mole ratio between CaNO3 and CaCl2, which is a 1-to-1 ratio. We then multiply that by the molar mass of CaNO3, which is 148.1 grams per mole, to get the mass of CaNO3 of 32.7 grams. So we plug that in again to our equation. Actual yield of 21.5 grams of CaNO3 over theoretical yield of 32.7 grams of CaNO3 times 100 to get the percent yield of 65.8%. On to question 3. When 312.7 grams of Al2SO4 reacts with plenty of magnesium, what is the percent yield when 38.5 grams of aluminum are formed? So pretty much a side note, whenever they say plenty of some sort of element or some sort of substance, that means that the mass of that substance is not going to matter at all. The one you really need to worry about is the one that they give you on the reactant side. So this one would be Al2SO4. And so first we write out the balanced equation of Al2SO4 plus 3Mg combined to form 3MgSO4 plus 2Al. We then need to find the mass of aluminum by multiplying 312.7 grams of Al2SO4 by its molar mass, which is 1 mole of Al2SO4 over 342.17 grams of Al2SO4. We then multiply that by the mole-to-mole ratio between Al and Al2SO4, which is a 2-to-1 ratio here. And then we multiply that by the molar mass of aluminum, which is 26.98.